Hello. So what I have here, this is my resource for geologic geometry, and this is relating to skew boreholes um, for the mining geometry section. So what I have here is, just to start off, it's the 3D contour map that I have created already, and I have two skew boreholes represented by these two dowels here, um, cutting down through my map, through my contours. So just to start off, kind of the main reason that I created this is to help pupils visualize what they're doing when they're creating skew boreholes. So I know that a lot of the time when pupils are drawing these questions, the only thing they're seeing is two lines on a piece of paper. So what they would see is just to look in at a plan view like this. So here we can see kind of this skew borehole is going in a northeast direction, and this one is kind of going in kind of a southwest direction. So pupils would see that, and they'd be able to see our contours as well. And then if we're looking at our elevation, so we can see our two skew boreholes like that. So they're very close to being parallel with each other, but they're not quite parallel here in this view. So with this here, pupils can kind of see how their lines are affecting the contours, where holes are being cut through the land, and how this kind of affects the contour map in general. So what we have here is we can see exactly each point that our contour is going through, that our skew borehole is going through each contour, without having to look at our elevation and trying to visualize things, which is a key thing in my opinion for pupils who are just starting off in this topic. That the last thing you want to be doing is trying to visualize things in your head at too soon a stage, getting confused, and then you just don't understand what you're doing. So you can see the same thing over here. We can see exactly where each one of our skew boreholes is going to cut through our land, or cut through our contour lines. And what we can then do from this question is, right, so I have drawn in behind, just using a sheet of paper, my two skew boreholes and behind, like that there. And what I can do is I can use this to say to pupils, okay, so the top of our stratum is going to be at a height of 30 meters. So we could say that that is the top of our stratum there, and for our skew borehole A, and then the top of our stratum for skew borehole B is going to be at a height of 20 meters. So what we can do is pupils can then look at an elevation and say, okay, from what the teacher just told us, where would our stratum be if we're looking at skew borehole A? So I know he told us it's going to be at 30 meters. That means our top of our stratum is going to be here, and then it's going to be here for skew borehole B. So this is just, again, helping with pupils to visualize what they're doing here. Because oftentimes, again, as I said before, pupils are told where the stratum is, they're just told to draw a line here, and they don't really understand what they're doing. So pupils can really visualize what they're doing. They can see, right, so I know that my stratum is going to be along this line here. So that's going to be along my stratum there. So pupils will be able to see that when they look in here, then. So that when they look in the elevation, they can see with the stratum that I've drawn. And in my opinion, that would help them being able to visualize what they're doing. And then from this here, we can then generate the same thing again. So we can draw the bottom. We have the two bottom points of our stratum, and like I say, we could put another point up here. You know yourself. And pupils will be able to manipulate this, and we can actually create a question from this. So if we say, right, so these are our contour lines, what I want you to do then is I want you to, using two skew boreholes, very similar to what I have created here, I want you to take an A3 sheet, draw it out, and try and complete the question. So if I tell you that the stratum is at point A, the top of the stratum is at point A, is at a height of 30 meters for skew borehole A, and 20 meters for skew borehole B, and then pupils can generate and complete a question based on this. And then they'll always have a reference point to come back to then. If pupils do complete this question, they can say, okay, I remember visualizing this before, but I cannot remember how I'm doing it now, but I happen to have my old skew borehole question that I completed based around the practical model that we have at the top of the class. So what I'm going to do is I'm going to take out my old sheet, and I'm going to look at this, and I can see exactly where I've generated my lines from. So I can see, okay, so this might be the top of our stratum for Skew borehole A, so the top of my stratum is going to be here, and then maybe that'll be another point down here, and people can just really visualize what they're doing. It's just, you know, kind of helpful tool for them to see, okay, so I now see what I was doing there, and they don't get bogged down and, you know, maybe a mess of lines, or just they don't understand why they drew a line here or why they drew a line there, that they can just always have a reference point to come back to. And I think this practical model here is a very good example of this.